Hey guys, welcome to Simplifysics. In this video, we will be talking about convex lenses and concave lenses. Now here, there's a concave lens on the left and there's a convex lens on the right. The concave lens has got thicker edges, and when you see something from it, it appears diminished. The convex lens has got sharper edges, and when you see something from it, it appears magnified. So can you identify which of these lenses is convex and which is concave? So this is a biconvex lens and a biconcave lens. This is a plano-convex and a plano-concave lens, and this one is a concavo-convex and a convexo-concave lens. So if you look at any lens, it has got two spherical surfaces. The lens could be thought of as being an intersection of two spheres. These spheres would have their own centers, and these are called the centers of curvature. A line passing through both these centers is called the principal axis. This is the maximum aperture. Aperture is a term that is used to signify the area of light that can go into the lens. So do understand that aperture is not a line but an area. The point at which the aperture intersects the principal axis is the optical center O, and the distance from the centers of curvature to the optical center is called the radius of curvature. You could consider that a biconvex lens is made up of several glass pieces such as glass slabs and prisms. A ray of light that passes through the glass slab would go undeviated, but other rays that pass through the prisms would be deviated, and all these rays would converge at a point. So that's the reason why a convex lens is also called a convergent lens. The point at which all these rays converge is called the principal focus, and this is the real focus because the rays actually meet. Now, if these rays were parallel to each other but not parallel to the principal axis, they would still converge onto a point called the focus, and there could be several such foci. In fact, there would be infinite foci, and all these foci would lie on a plane that's called the focal plane. Similarly, you could consider a concave lens also to be made up of several glass pieces such as these. A ray of light passing through the glass slab would go undeviated, but other rays would be deviated in such a manner that they diverge out. So a concave lens is also called a divergent lens. Now, if these rays were traced backward, they would appear to emerge from a point called the principal focus. Now, this principal focus is virtual because the rays are extended and they are not actually meeting. They appear to meet. So here I've got two lenses, a convex lens and a concave lens. A light ray parallel to the principal axis would pass through the focus in the convex lens, and a light ray parallel to the principal axis would appear to emerge from the focus in the concave lens. The distance between the optical center and the principal focus is said to be the focal length. Now, this focal length is equal to half the radius of curvature. I'm not going to prove this over here because the proof is not there in your syllabus. And as expected, the focal length is inversely proportional to the refractive index. This is because if the refractive index is greater, then the deviation would be greater and the focal length would reduce. So because the lens has got two spherical surfaces, it is obvious that there would be two foci and therefore there would be two focal lengths. So with a convex lens, if a ray of light first passes through the focus and then emerges parallel to the principal axis, the focus that it has passed through is the first focus and the corresponding focal length is the first focal length. And if the ray passed through the focus after passing through the lens, this focus would be called the second focus and the corresponding focal length would be called the second focal length. Similarly, for a concave lens, if a ray of light travels through the lens and then emerges parallel to the principal axis, the point that it was approaching is the first focus and the corresponding focal length is the first focal length. If the ray of light diverged from the concave lens such that the diverged ray emerged from the focus, this focus would be called the second focus and the corresponding focal length would be called the second focal length. And now the summary of this video. A convex lens converges parallel rays of light, whereas a concave lens causes them to diverge. The point at which parallel rays actually meet or appear to meet after passing through a lens is called the focus. A lens can have infinite foci and all these foci lie on the focal plane. The perpendicular distance between the optical center and the focal plane is called the focal length. And a biconvex lens or a biconcave lens would have two foci and therefore two focal lengths. So that's all for now, guys. In the next video we will be discussing image formation by lenses.